Problem number 4. Mrs. Williams gave an exam to a group of 5 students. She entered the scores in random order into a spreadsheet which recalculated the class average after each score was entered. Mrs. Williams noticed that after each score was entered, the average was always an integer. The scores listed in ascending order are 71, 76, 80, 82, and 91. What was the last score Mrs. Williams entered? Alright, well, let's think about what she's doing here. So she takes one score, she enters it. Of course, the average is going to be an integer because there's only one score. And the scores are all integers. Then she enters another score. And the program that she's working with, the spreadsheet she's working with, will add them together and divide by the number of scores that she's entered so far. So she has 2 scores, and so the sum of the scores divided by 2 is an integer. So that means what? That means that the first 2 numbers have to be either both even, okay? They have to be an even plus an even, or they would have to be an odd plus an odd. Okay, so we can't have an even and an odd. And let's see, so 71 is odd and 91 is odd and the rest are even. Okay, so we could enter 71 and 91 first. Or we could enter 76 and 80, 76 and 82, or 80 and 82. Okay. So, but that doesn't really narrow it down much. And the key to this problem is actually the next step. She enters the 3rd score. The program adds it up, or adds the 3 scores and divides by 3. So the sum of the first 3 scores that she enters has to be divisible by 3. So you might be asking, well, how could we find a set of 3 scores that is divisible by 3? And the key here is to recognize that really all these numbers are a multiple of 3 plus a remainder. Okay, so 71 could be broken up into 3 times some number plus a remainder, right? Excuse me. And we'll just call that R1. Okay, and then 76 could be broken up into 3 times some integer plus a remainder. Okay, so when we add up 3 of those numbers, we'll end up with 3a plus a remainder, and 3b plus a remainder, and say 3c plus a remainder. And if I reorder that, 3a plus 3b plus 3c, that's automatically divisible by 3. So if the sum of the remainders is divisible by 3, then the whole thing will be divisible by 3. Okay? So we just really need to look at the remainders when we divide these by 3. Okay? So let's do that. Let's look at the remainders. So, okay, let's start with 71. Alright, 71, that's just going to be, what, 11, so 9. That's going to be a remainder of 2, right? Whoops. I think I made a mistake here because I meant to put the 9 here, and this should be 3. Alright, it's the remainder of 2. It doesn't really matter as long as you recognize that it's a remainder of 2. Alright, so let's take a look at 76 divided by 3. So again, that's 6, 16, 5 with a remainder of 1. Right? So here we have a remainder of 1. And if I divide 3 into 80, okay, that's going to be 2, 6, 26, 18. That's going to be a remainder of 2. And let's see, 3 into 82 is what? 12. Whoops, is that right? 82. Okay. So let's see. Something doesn't look right. Oh yeah, this is a 2. That's why. All right. So 7 times 3 is 21. We'll have a remainder of 1. All right. And 3 into 91. Okay, so that's 3, 9, and then we have 1, so it's 30 with a remainder of 1. Okay, so the remainders are 2, 1, 2, 1, or 1. Okay? So we want the sum of the 3 remainders to be divisible by 3, which means that the only combination of remainders that would give us something divisible by 3 is only if I took the numbers with a remainder of 1, right? Because then this would just be 1 plus 1 plus 1. None of the other ones are going to work. You know, we don't have any remainder of 0, so you know, if I use any of the 2's, we'd need another 2 for the third one, or we'd need the 2 and a 1 and a 0 or something. So the only combination that works are the ones that are divisible, are the ones that have a remainder of 1. So that we know now that the first 3 numbers have to be 76 and 82 and 91. Okay? Which tells me that the first 2 have to be 76 and 82, because we know that the sum of the first 2 divided by 2 was an integer. The sum of the first 3 divided by 3 is an integer. And so these are the first 3. And so that takes care of 76, 82, and 91. So we're left with 71 and 80. So, all right, so when we add the fourth one in, we're going to end up dividing it by 4. All right, and if we add these 3 numbers up, we get an even plus an odd, so that's going to be odd, right? So in order to get an even number, we would have to add an odd number to it. So the next number has to be 71. Okay, does that make sense? That's the only one that's going to give us an even number for the sum of the first 4. And we know that if it's an integer, when we divide by 4, it has to at least be divisible by 2, and so it has to be even. Okay, so that's the only one that's going to work. And you know, you could check it, but you got to assume that it's divisible by 4 as well, the sum of these 4. Okay, so then the fifth one, that takes care of 71, and then the fifth one has to be 80. Okay, and because that's the only one left. I mean, we could check it and show that when we add these all up, it's divisible by 5. And you can see that, okay, you have 6 and 2 is 8, plus 2 more is 10, plus a 0. So it's going to end, this number is going to end in a 0, so it'll be divisible by 5. So that's our answer. And the hardest part of this one was figuring out what the first 3 numbers were, because figuring out which 3 numbers, when you add them together, are divisible by 3 is the tricky thing. And the key is to look at the remainders, to recognize that every number, no matter what it is a multiple of 3 plus a remainder. The remainder might be 0, but you know, when you add up numbers, if you look at the remainders, as long as the remainders add up to something that's divisible by 3, then the whole thing is divisible by 3. Okay? Make sense? Alright, so the answer is 80.